So what we talked about now is the so-called intrinsic value all the time. So always compare the share price with the exercise price. So the difference between where the share price is at a certain point of time and the price that is written on these contracts. And the difference between these two is called the intrinsic value of an option, easy to calculate. But there's something else to an option, and that's the so-called time value. Now what is that? Basically, we don't know now if the share price will be 590, if the share price will be 600, or if the share price will be 500. We have no idea. There's a certain chance that the share price will go in a certain direction. The easiest way to think of that one is the long call. Right, so this is the easiest one to understand. So we don't know where the share price will end up with. But now we can think of, well, if there is a very high chance that the share price is rising, there's a very high chance that the option is getting into the money and will be worth a lot, and therefore lots of people would be interested in buying these options. So just the chance that the option might get into the money is giving the option already some value. So even though if today the share price is 610 and the exercise price is 610 too, so the intrinsic value in my example is exactly exercise price 610, share price 610, the difference between them, 0. That means in that moment you would think the contract is worth nothing. But that's not true, because there's a chance that tomorrow the option might get into the money. Or if the option is running for 3 months, there's a good chance that the option might actually be very profitable. And that chance, if you translate that chance into dollar values, that's the so-called time value. So the longer the option is running, the more time you have, the bigger the chance that something will happen. And therefore, the higher the time value. Also, the lower the strike price for a call option, the bigger the chance that it becomes profitable. And again, the bigger the time value will be, and so on. So basically, the $10 here you can think of as a total of intrinsic value plus time value equals how much people are willing to pay for that option. Right, so that's meant here by this formula. The option premium is how much the option is traded for, and it's traded for at least the intrinsic value plus the chance that the option gets into the money and becomes valuable. And if you have more advanced finance classes, you will use a Black and Scholes formula for that one. It's a very, very famous formula. People got a Nobel Prize for it. I think Merton was involved in that one too. It's an absolute standard thing that they use in finance, but we don't go into that much detail in this class. But the main kicker of that formula is it's basically using the share price volatility and how much time the option has still to run in order to calculate the total time value plus intrinsic value, and therefore give a good estimation or calculation how much an option is worth at any moment in time. Very widely used. I think later on I will give you a movie to watch as well where they talk about rocket scientists and quants. So this is because there's so much math involved in these things. They often employ mathematicians, physics, people that not necessarily have a finance or economics background, but they are very, very good at math. And they can do all these things too. That's the reason why they have this slang term for these type of people. So this is basically a printout of options. We've got call and put. Let's see, these are all the call things. These are all the put things. These are the last prices. And we've got here the strike price of these options. Underlying stock price, so the current stock price is 666.80. Your first job is take a highlighter or pen or whatever and mark which of these options are in the money so that they have an intrinsic value. And be careful, we've got call and put, so don't mix these two up. And then once you figure out which ones are in the money, you can calculate the intrinsic value, so how much they are in the money. And once you've got the intrinsic value, somewhere in the table there's also the premium, you can calculate the time value of each of these options. So basically you're going backwards. You first look which one is in the money, then calculate for each of the ones that are in the money the intrinsic value, and then you can calculate the time value afterwards. here. So these are the strike price, basically the exercise price. Last is for how much the option, the piece of paper itself, has been traded for. Volume is just how much trading there was, and open interest is how much people would like to trade, but at a slightly different price. And here's just a repetition with a put. Highlight the options that are in the money. So in the money means that if you were to exercise it straight away, you could make a profit. Or it's worth using that piece of paper. So call, is it worth using the right to buy a share at 680 if you can buy it in the market at 666? No, it's worth nothing. And that's true for all of them. So all of these call options, in this moment, nobody would use the call option. The intrinsic value of these call options is all 0, 0, 0, 0. So with the put option, that is the right to sell the shares. Would you use the right to sell the share at 680 if in the market you can earn only 666? Yes, people would use that right. Now we can go over to the intrinsic value. So how much is that right worth? It's just by the intrinsic value, so without any speculation. So if you can sell the share at 680, you can buy it at the same time in the market at 666.80. So the intrinsic value would be, for the put, $13.20, thank you. So far so good, $13.20. People, however, traded at $13.50, more. And what's the difference? So the premium, they traded at $13.50. We calculate the intrinsic value was $13.20. So the time value automatically must be 30 cents. Now maybe to make it more intuitive, how come that people pay 30 cents too much for the October call? My guess is this whole thing has been printed out in September. Where are the 30 cents coming from? So it's time value, because there's still time that the share price might fluctuate even more. In this case here, for the put option, the share price might drop even lower, and then the option will become even more valuable. That's the reason why people are willing to pay more than $13.20 for the thing, because there's speculative value in that option too. There's a chance that the option becomes even more valuable than it is now, and that is the time value. And of course, the longer the time, the more time value there is. And we can see that nicely on the call option side here. Because if you look at the October call, we already decided all the call options are out of the money. That means the intrinsic value of all the call options is exactly 0. Still, they're being traded at positive prices. That means here the time value of the October call is simply 31 cents. Because the premium is 31 cents. Intrinsic value was 0. That means the time value is the difference left over, 31 cents. Look at the time value here, $23. Or April, $56. So of course, the longer the time till the settlement date, the bigger the chance that the option is getting into the money, and therefore the bigger the time value. Same thing here too. The time value with time gets bigger and bigger and bigger and bigger. Remember, all these options here are $13.20 in the money, but they are worth in the market considerably more because we have to put the time value on top. And the time value we don't calculate here in class, but that's basically, I do that with a tricky formula here, putting in volatility time, all kinds of stuff. Speculation. So we can use options and futures either for hedging, so if you have a natural interest in that item, or we can use it for speculation. And there's often in the news, people are against speculators, especially politicians. There's thought of if you should forbid all kinds of option and future trading. Warren Buffett, very famous, didn't like it too much either. But there's some advantages of having speculators in the market too. So number one, they could be on the other side of the hedges. So if I want to hedge something and I want to get, for example, I want to go long on a call, that means I need to find somebody, or there must be somebody else in the market who wants to go short on the call, who wants to sell me the call. And if a speculator is willing to do it, I can basically get rid of my risk, because I buy the call for hedging or buy insurance, and put the risk onto him. And if the speculator is happy to get that risk, that's fine. Right? Of course, the speculator is hoping that the price will move in such a way that I throw my contract in the bin, that I don't exercise it. And therefore, speculators are basically taking on risk of other people, and also they provide liquidity. So the more people are in the market, the more buying and selling happens, and the more liquid the market is. And liquidity by itself is something positive, because I might change my mind. I might decide, no, I don't want to hedge anymore. I just want to get rid of my options. And the more buyers there are for these options, the easier it is for me. So it's increasing, in that sense, market efficiency. Then we have one more product. So we talked about forward and futures, pretty much the same thing, just that one has counterparty risk and is non-standardized, while the other one is standardized. Then we talked about options. There we could see that it's like an asymmetric thing. So unlike a future, it's not a straight line, but it's got that kink there at the exercise price, because the long side has a choice. They can choose. Short side has the obligation. That makes that kink here, because we can choose to exercise it or not. And now the third instrument that we want to talk about shortly is interest rate swaps. We talk about that again later when we have done more about banking. Just because it's a financial derivative, talking quickly about it here too. We've got two entities, Wells Fargo and IBM. And what they're literally doing is they're swapping cash flows. So Wells Fargo says, listen, I'm going to pay you 4% interest on $10 million. The LIBOR interest, which is an interest London interbank offer rate, so that's an interest rate, a variable interest rate set in London. It's an average rate between different banks, not that important right now, which is fluctuating. And Wells Fargo says, I pay you that interest rate plus 4% on a certain amount of money. And in return, IBM is going to pay Wells Fargo 6% fixed. So they're just swapping cash flows. Wells Fargo is giving a variable cash flow away, and therefore in return gets a fixed cash flow in return. Now why might they do that? Here in this example, for example, IBM has a variable rate loan. Let's say, for example, they have a loan where they have to pay LIBOR plus 5%. And they're afraid that the LIBOR rate might go very, very high. Then their loan interest rate would go higher and higher and higher. And that's a risk for them. And so we don't want to have that risk. We want to have insurance. And one way to get that insurance is to simply swap. So what they're doing now is they're paying somebody else 6% fixed. So they know for sure they always have to pay 6%. And they get in return 4% plus LIBOR. And they use the 4% plus LIBOR to cover most of the costs for the LIBOR plus 5%. So in the end, basically they get a fixed rate loan now, where they have here to pay 1% more than they're receiving. So if the LIBOR goes up, they have to pay more for the loan, but they're receiving more on this side too. So they don't care that the LIBOR is going up. They're paying basically always 1% more here for their loan that they're getting in here, plus they have to pay 6%, so they basically made their loan towards a 7% fixed loan by swapping things around. So they can change the structure of their risk on their balance sheet by using swaps. And for Wells Fargo, the idea might have been exactly the other way around. So they wanted to get rid of some kind of variable income, and they wanted to get fixed income. There's a million different reasons why people use swaps. But the basic idea here of a swap is you're just swapping cash flows with somebody else. And you can do that, here it's just a plain vanilla swap, fixed against variable, but you can do that across different currencies as well. So you could do swap, for example, interest payments in Australian dollar against interest payments in US dollars. There's a million different kind of swaps. For this class here, it's absolutely sufficient if you have a basic idea of the swap, and we can go a little bit deeper later on when we talk about banking and how banks use swaps to get rid of risk. Good, so we have the summary. I'm almost done, just to race through quick. So remember, long means buy, short means sell. Call is the right to buy, but you don't have to buy. Put is the right to sell. When we've got the writer side and the holder side, the writer is much more riskier because they've got the obligation. The holder has the choice. And we talked about futures as well, options. So that's the difference between